All right.
I couldn't stop looking at it.
So we're almost done. We have 2 more days of like instruction,
Yes.
and then the final exam, which would be this Friday, and then we're done. So, any questions on what we did last week? That was the product rule and quotient rule. Good. All right. So today we're going to talk about something called the chain rule. And the chain rule is a way to differentiate functions that are compositions of other functions. Okay? That's what this is. It's a way to find derivatives of functions which are compositions of other functions. For example, like we know how to find the derivative of sine x, it's just cosine x, right? But we don't know how to find the function or the derivative of y equals sine of 3x, for example. Thank you. This is a composition of 2 functions. And we don't know how to find the derivative of y equals sine to the 5th of x, right? So even though we know how to find the derivative of sine x, we don't know how to find the derivative of these 2 functions because they're compositions of sine with something else. Okay? So here's the chain rule. The chain rule says if you have the derivative of a composition, so you could write a composition as f of g of x. That's a way to write composition of 2 functions. Like for example, in this case, g of x would be 3x, f of x would be sine x. So if you took f of g of x, in that case, f is sine x, g is 3x. If you took f of g of x, you'd get that, right? In this case, f of x is x to the 5th, and g of x is sine x. So here you have f is x to the 5th, g is sine x. This is really just f of g of x. Does everybody see that? Okay. So if you have something of this form, f of g of x, its derivative is f prime of g of x times g prime of x. So, for the 2 examples I've given so far, if you have y equals sine 3x, essentially what you're going to do is you're going to take the derivative of sine, but evaluate it at 3x. So you're going to take cosine of 3x times, that's this times here, the derivative of g of x, which is the derivative of 3x. 3. That's it. So one way to think of it a little bit more intuitively instead of so like abstractly like this is you can just think of it, it's like sine something. The derivative of sine something is cosine something. But then you just have to take the derivative of that something and multiply it at the end. Okay? That's kind of like the easiest way to think about it. So in this second example, if I have y equals sine to the 5th x, think of this as sine x all to the 5th power. That's really what sine to the 5th x is, right? So just think of it as something to the 5th power. The derivative of something to the 5th power is 5 times something to the 4th power, right? So y prime is going to be 5 times that something, unchanged, to the 4th power, times the derivative of that something. sine x. And see how the chain rule works. So if it was something like y equals 2x squared plus 3x minus 1, all to the third power. Essentially, you have something to the third power. Forget about what this is. It doesn't matter what this is. It's going to be 3 times this squared. That's where you're going to start. 3 times this stuff, in parentheses, unchanged, squared. But then times the derivative of that stuff in parentheses, 4x plus 3. Okay. What if it was something like y equals 5 square root of 3x plus 7? So this is really 5 times, I'm just rewriting it as a power, 5 times 3x plus 7 to the half power.
Right.
So it's really 5 times something to the half power. That derivative would be 5 halves times something to the negative 1/2 power, right? So that's where I'm going to start. It's going to be 5 halves times 3x plus 7 to the negative half, but then times 3. That's the derivative of 3x plus 7. If I had find the derivative of tangent of x to the third power. Well, it's tangent something. Its derivative is secant squared something. So this is going to be secant squared x cubed times 3x squared. This is making sense?
Yep.
Let me just do one more example. And I think the one that might look a little bit different.
So for like delta math, we're not multiplying those out, we're just writing that.
Yeah, you don't have to simplify it at all. It says leave your answer in any form. So
Okay.
you could leave it just like this. How about this? What if I have the derivative of 4 secant squared x. Okay, so ultimately this is really, I'm just rewriting it now. I'm not taking the derivative yet. This is really 4 times something squared. 4 times something squared. The derivative of 4 times something squared is 8 times something, right? So this is going to be 8 times secant x. But then by the chain rule, you have to then multiply by the derivative of something. So the derivative of secant x would be secant x tangent x. Does everybody see where I got all the parts of that? The derivative of secant tangent. So I took 8 times the stuff in parentheses unchanged to the first power, and you're done with that, and then times the derivative of this stuff in parentheses, which is secant x tangent. Any questions? This can be combined with other rules too, like, for example, the product rule. Like I could have something like y equals 5x minus 1 cubed times 3x plus 7 to the fourth power. And I could take its derivative using the product rule, but in the middle of the product rule, when it comes time to take the derivative of this, you got to use the chain rule. And when it comes time to take the derivative of this, you got to use the chain rule. So this would be the product rule overall, But in the middle of the product rule, you're using the chain rule twice. So this would be the first times the derivative of the second, which is 4 times 3x plus 7 cubed times 3, plus second, unchanged, times the derivative of that first piece, which is 3 times 5x minus 1 squared times 5. So like this is like u. This whole thing here is v prime plus v. And this whole thing here is u prime. Everybody see that?
Yep.
Any questions on that? Okay. So the homework sent out to math is just called chain rule. That's all it's called. Okay?
Yep.